Hi class, let's take a look at problem 302. And on problem 302, this one is already technically in standard form. So I'm just gonna rewrite it with the a and the b squared. So in this case, we technically have an x to the second over a 4 squared minus a y to the second over a 3 squared, and this is equal to 1. So we technically have a hyperbola with actual center at the origin, technically the values of a, and I'm just using the formula. It's equal to the values of 4 and b is equal to the values of 3. Now the hyperbola, it's going to have these actual lines from the center. So the actual lines, or in this case the asymptotes, are going to be at the values of y is equal to b over a plus or minus x. So for us, this is going to be 3/4. So plus and minus 3/4 of x. Now remember that these lines from the origin are actually going to be dotted. So they're not technically there. So 3/4 is going to be 1, 2, 3, and then 1, 2, 3, 4. It's going to be the first one. And let me actually place it. So 3, 4, it's going to be the first one. So our line, it's going to go in this direction. And then -3 and 4, it's going to go in this direction. Okay, the next order of business is the direction in terms of how the hyperbola it's going to be running. Because it's already in standard form and your x's are positive, it's going to go along the x's. So in this case, it's going to go along the x's, and we're looking for the values of a. A is equal to 4 units. So I'm just going to place the values of 4 here, and technically -4. And then I'm just going to follow the general shape. So your general shape, it's going to have 2 hyperbolas in this direction. So from here, I'm just going to create the actual shape of these. And that's pretty much it for this sketch. Let me show you what this one looks with technology. In this case, you can see the values of AF4, and then here's your lines. Obviously with technology, it looks way better. So I'm just putting the arrows on the actual lines. So that's actually it for problem 302. It's actually in standard form. And once again, because of the actual value of the minus, we have a hyperbola. If it had been a plus, then you had an ellipse. Let me move on to problem 306, which is going to take like 1 minute. And the first thing I'm going to do is I'm going to express it as a function. So in this case, I'm going to be dividing by x's and x's. And for this particular equation, you have a y is equal to 4 over x. Technically, x cannot equal to 0 because we divided by x's. And this is going to actually display it as an asymptote. Because we have that constant of the 4 there, let me pick some value so we can have at least some coordinate points as a reference. Our parent graph for this one, it's gonna actually be a function. So this is another type of hyperbola, but it's from the content of the first exam. So this is what it's gonna look like. So let me pick a couple of values. So I'll just say let x is equal to 4. Then your y value, it's going to be 4 over 4 or 1, or technically 4 comma 1. So we're going to have 1 point there. And then if we have x is equal to -4, your y value is going to be 4 over -4 or -1. So this will be -4 comma -1, which is here. Now I'm just using those values as a reference. After that, I'm just going to follow the basic shape, and let me show you what the basic shape looks like with technology. That's what it looks for with technology. At your point 4 comma 1, that happens to be here, -4 comma 1. So as long as you have the basic shape as the parent graph, that would be fine. So for this one, I'm just going to draw that you have a hyperbola going in this direction and another hyperbola going in this direction, passing through those 2 points. Any points are fine. I'm just using 4 because it would have been easier to actually plot. That's actually it for problem 306. Let me once again show you what this one looks like with technology. And we typically just plot one coordinate point and then we mimic the parent graph. So once again, that's actually it for problem 306.